Good morning, students. Today we are going to discuss about laboratory sessions. Uh, so you see in CG lab, so we have total 9 programs and one mini project we have to do. So all are OpenGL programs. And again, examination pattern will be same as like DBMS we did in the previous semester. Everything will be same. Okay. So and software, regarding software, so I have shared software installation procedure in WhatsApp. Please download that Microsoft Visual C++ 2008 version in your laptop or desktop and follow the steps whatever given in the list. Okay, so once it is installed, or if it is already available and if it is not working, means you uninstall and again you have to install once again. Okay, so then it will work. So please, without missing any steps, you follow all the steps and you just let me know if you face any issues in the installation of software. Okay, so that you can able to execute the CG programs. Okay, so for this coming Monday class, so I'm going to explain a Bresenham's line drawing algorithm so that you can able to work parallelly. Okay, so I have, so it's installed in my laptop and I executed that program. So please from your end install the same and execute the programs so according to uh, the syllabus coverage. Okay, so before going to the program, so just general information. So whatever we have discussed the Bresenham's line drawing algorithm in theory, and we have taken one example and we solved the problem, and we have find out the decision parameter. Based on that we have derived or we have find out the new coordinate values for the given two endpoints, and we roughly plotted the same line or draw the line in xy plane, that is in two-dimensional plane, by considering the values. Okay, so similarly in laboratory also we have to use the same logic what we already learned, but the thing is the tracing is quite different when compared to theoretical that problem solving. So like for the examination point of view, so in theory exam if they given question to digitize that line using the given two endpoints and we have the steps we followed. But in case of program tracing, that is because we have written the program little different, because logic wise it is like logic same but the steps may be different. Okay, so that is we can say. Okay, so we have to, but at the end, so the whatever we are computing the values, it should be same. Okay, the methodology is different, logic is same, so that you have to follow. Okay, so let's start with the first program, Bresenham's line drawing algorithm. Implement the Bresenham's line drawing algorithm for all types of slopes. So we know the slopes m value, right? So for all types of all possible slopes, we have to execute. It should satisfy for all types of slopes. Okay. So for the given slope value. So what are the other types of slopes available? So we have four different types of slopes. One is positive slope, negative slope, zero slope, and undefined slope. So what is this positive slope? Increasing the line, whatever we are going to draw the line, it should be in the increasing order. It should be in the positive increasing order. So negative slope in the sense the line going towards in the negative direction, that is in the decrement value, decreasing the value. So zero slope means it's horizontal. So undefined slope means it is vertical line. So like this we have a four different scenarios or four different types of slopes. Okay, so our program should support these four types of slopes. If you given the input values for any such cases, for any such type of slopes, it should execute. So that is what the question. Let's move on to the program. So as we know, so in our C programming or C++ programming, we used to include the headers. So where which contains the functions. So similarly, here also we are going to use graphics library functions. So we already discussed in our first module that in theory, that is the different graphics library functions which are available in OpenGL is GL, GLU and GLUT. Graphics library, graphics library utility, graphics library utility toolkit. Okay, so just I'm going to add those, and you can use, like you can save your program with .cpp .c. Okay, so C or C++ program you can implement. Okay, so then we need, let's continue. So we need, as I said, in order to draw any line, at least we need two endpoints, means two coordinate values, that is point 1 and point 2. Okay, so point 1, suppose you can consider x1 comma y1, point 2 x2 comma y2. So that is what I'm going to initialize my integer, the coordinate values of integer type x1 y1 x2 y2. And I'm going to set up my window. I'm going to initialize my projection view or projection window with the following OpenGL inbuilt functions. So what is the first function? GL clear color. So what it is doing and what is the use of this function in my init? So the set window color, which contains four parameters, that is R, G, B and A, red, green, blue and alpha. So this GL clear color specifies the all these colors with the alpha values used by GL clear to clear the color buffer. Okay, so the whatever the GL clear function is going to specify the color format, so those values it is going to store and it is going to clear those color buffers. Okay, so GL clear, GL color buffer bit, so it's a constant GL color buffer bit we are using in GL clear function. So this function is used to clear the window, nothing but it is going to clears the OpenGL color buffer. Suppose if I executed one program right now, after executing the program multiple times, if I move on to the next program or to try to execute the program, same program again, so the previous, whatever the previous iterations, previous execution you have done, if any the buffer, color buffers resides in the memory, so it is going to clear that. So that is what the function of this GL clear. Okay, so next we'll move on to the third function, GL matrix mode, with the mode GL underscore projection. So basically what this GL matrix mode is used for. We know that the values of any image or the data which stored in terms of a matrix. Okay, so the GL matrix mode we are going to set to the current matrix mode. Means suppose if I want to draw a line now, so I'm going to initialize my matrix to the current matrix. It should not contain any value. From here onwards it is going to ready to store those values for the given image or geometric primitive. So this matrix mode is of four type. It takes an input, the mode, and that mode will be of four different types. So that is GL model view, GL projection, GL texture, GL color. So in this example I am taking GL underscore projection because I am whatever the values I'm going to take for the any object, okay, for the current values. Once I have stored my values in the matrix, and I'm going to apply those values or any operations, the matrix operations, so to my projection matrix stock, so that you can able to display your image or project your image over the projection screen or the display window. So similarly I have a model view, texture and color. Okay, the same concept, that but the viewing is a different concept, different you know um, aspects we are going to consider here. Okay, so that is about matrix mode GL projection. And the fourth one is GLU ortho 2D. So that is a ortho function with the two-dimensional space. So and this function is available in graphics library utility. So with the four values 0 comma 500, you can give any values, just I have given consider 0 comma 500 and 0 comma 500. So this function basically is used for to set up your coordinate space as a 2D. It is going to set up your 2D coordinate space or projection area. So how it will be means like this. So the initial coordinates will be the origin, that is 0 comma 0, that is 0 comma 500, 0 comma 500. This is the space where you are going to draw your line. So that is what, this is a two-dimensional space, that is what ortho 2D, that is what is why 2D, because x and y, I am using only x and y plane, that's why it is 2D, two-dimensional coordinate space. Okay, that is the function of this GLU ortho 2D. So these are the four different inbuilt functions we are going to use in order to set up our my projection view or projection window. Okay, next I'll move on to the next function. So draw pixel, wide draw pixel, int x, int y. So I'm going to, because in order to draw any pixel I need two coordinate value, that is x and y. So same thing. And I'm going to begin, you know this function begin format, GL begin, and what type you are using, that is point, right? Pixel you are going to draw, right? That the available geometric the function is gl underscore points, which specify a point. If suppose it is gl underscore line, which specifies a line. Okay, so and I'm using one more function, vertex 2I x comma y, that is gl. So all these functions begin, vertex, end, all these functions are available in graphics library. That's why the name prefix, the GL, we are using the prefix as GL as prefix to your function. And this vertex 2i, that is 2 means indicates the two dimensional, that is we need two coordinate values, that is x, y, and I is of integer type. So that is the function and end of the function. So once you have find out the coordinate values in all the iterations, those values will be passed to this function, and this function is able to, plot the pixel on the screen. So that is the function of the draw the pixel. Next we'll move on to the draw line. So before going to this main, actual logic is present in this function. Before going to this main, actual logic is present in this function. Before going to this, we'll go to the main function and we'll come back, because the calling function is there. So next this wide display, right, display function. So here actually I'm going to line on y2. So and this display, once this that draw line function is going to execute, and then we can able to plot the line. Dash is the function which is used to draw all the objects. So what are the all possible objects which are we are able to draw on the screen for the given inputs? It is going to make it done. Okay, so that is GL function. This is the display function. Just by calling the draw, draw line function, it is going to perform all the iterations, and it is going to find out the coordinate values, so that it can able to draw all the possible objects in the for the given inputs. Next, main function, int main, int args, character star argv, arguments, variables we're passing, the printf again I need two different coordinate values end points. That's why x1 comma y1 x2 comma y2 I'm passing. As this is an integer type, the scanf, that is percentage d ampersand these values, and glut init ampersand just I'm going to initialize my glut window, that is glut init, using the given input parameters. Glut init display mode. So since I am using an RGB color model and it is of two-dimensional space, I am going to use these constant values, that is glut RGB, R operator, and glut single. So it's of RGB color model and it is of two-dimensional view. So that is what init display mode. And glut init window size. Here I am going to specify my window size. So where, what is the size of my window? So that is, I want to try to display my line on the screen, right? So where actually this line is going to be appear. So that size I am going to, that window size, not, it's not a computer screen or your laptop screen. So inside your on top of your computer screen or laptop screen, there will be one more pop-up window is going to be rise. So on that screen it is going to draw the line. So that window size, yeah, this one what I'm going to, this, that is x y is, that is 50 comma, sorry, 500 comma 500. Next is glut init window position. So from where this window is going to be set up. So okay, that is 0 comma 0, means from the origin this window, whatever I told, no, that output window, output that pop-up window we are going to get. So from where, from which location it is going to be positioned. So that is the glut init window position. That 0 comma 0 means from the origin it is going to display. So next, glut create window. So that glut create window is nothing but just it is going to give the name of the algorithm or name of the program. So or you can say title of the program, that is Bresenham's line drawing algorithm. So this name, that this is the that Bresenham's line drawing algorithm is going to be appear on the left corner of your, on the top left corner of the display window. Next, my init. I'm going to call my init what I discussed in the first beginning. So it is going to call that. Then it is going to set up that window. Next is glut display func of my display. Then it is display function is going to be execute. It is going to call my display function. So that is what the my display function. Again, it is going to call inside. It is going to call again draw line function. Okay, so like that. So next, glut main loop. So all your whatever we executed so far, means performing all the iterations, it should be running in the loop. Okay, so that is the main loop. Glut main loop means inside. So your sequentially the all the iterations are going to be performed and it until the condition is satisfied. Okay, then I'm going to return those values. Okay, so this is about the main function. And now I told, right, draw line function, we left out with only the draw line function. Apart from that, we have gone through all. In main function we gone through, display function we have gone through, and my init function we have gone through, and draw pixel function we have gone through. All the four functions we have done. So now the main logic is present in the draw line function. How your draw line function is going to be work? Okay, and what are the inputs required? So that is the thing. So wide draw line, again I know I need two different coordinate values, right? X1 y1 x2 y2, same thing I am going to pass as a argument to my function. So and I need dx dy, that is difference in x value, difference in y value, and I is the number of iterations you are going to perform, and e is the decision parameter. So in theory, whatever we have considered, right, that same dx dy, that is nothing but x2 minus x1, y dy means y2 minus y1, and I is nothing but your k, and e is nothing but your pk. So when you are comparing with the theoretical problem solving. Okay, so these are the variables I required. Next, one more another variables, few intermediate variables what we required, like x and y. So next is increment the x value, increment y value, and inc1 incremented, so not incremented, just some naming convention they have given. INC1 and INC2. Okay, if you want, you can take any other naming convention also. So, and what is dx? We know, right? Dx, dy by dx we have calculated, right? Slope. M is equal to, what is the formula? M is equal to dy divided by dx, right? What is dy? Y2 minus y1. What is dx? X2 minus x1. Same thing I am considering here. So dx is equal to x2 minus x1, dy is equal to y2 minus y1. I have to calculate this value. Once you calculated this value, just you keep on applying these conditions. If suppose dx is less than 0, you check it. If dy is less than 0, perform this. If x2 is less than x1, perform this. If y2 is less than y1, you just perform this. Like this, based on the dx and dy value and x1 and x2, x1, x2 and y1 and y2 value, we are going to just increment or decrement the values based on the given condition. So okay, if after that, after performing these steps, then I'm going to, initially I'm going to assuming or assigning my x1 y1 value to x and y variables. Before starting any iteration, i'm going to assign I'm going to assign, or I'm going to put my x1, the first endpoint, that is x1 comma y1 value, to the other third variable x comma y. So I am going to assume, so this is my beginning, beginning point of the line drawing algorithm, beginning point. Okay, that is what x1 y1 is equal to x comma y. I am assigning my x1 value to x and y1 value to y. So what is x1? 20. Suppose if you are assuming my problem, whatever we have solved, so the input given is 20 comma 10 and 30 comma 18. So 20 is x1 and 10 is y1. Okay, in that case, your x value will be now 20 and y value will be 10. That is, the beginning end point will be 20 comma 10. Okay, understood? So that is, just I am assigning the values to the new variable. So that's why I'm using x comma y, and now this x comma y will be acts as now the starting point, that is x comma y, means 20 comma 10. From here it will start the iteration and it will find out the all the possible pixels, so till the condition satisfying. Okay, till the last end point to reach. Okay, that is 30 comma 18. We should reach 30 comma 18. Okay, so that is, let's the tracing begins. So if suppose dx is less than greater than dy, I will go to the solving. So I have solved this problem by taking same example. So whatever I did in the theory, so same I am taking for lab execution also. Okay. So just this is the how the logic will start. So now just click it. So all this calculation done, and I said all this condition fails. Okay, dx is less than 0. No, because 10 is not less than 0. Condition fail. Dy 8 is less than 0. Fail. X2 is less than x1. What is the x2? X2 is 30 and x1 will be 20. 30 is less than 20. No, condition fail. Y2 is less than, y2 is 18, y1 is 10. 8 is 18 is less than 10. No, condition fail. All the condition fails. Then what I did? I assigned x1 value to x, y1 value to y. So that is x is equal to 20, y is equal to 10. Okay, so now the first beginning value will be 20 comma 10. Okay, so now if dx is greater than dy, so this is the logic. Now if dx is greater than dy, so that is, what is the dx? Dx will be 10. Here I have calculated. Look at this. Dx is 10. Dy is 8. So a 10 is greater than 8. Yes. Condition is true. Then what I'm going to execute this part. Okay, I'm going to calculate. Before going to top pixel to find out the x and y value, right? Then only you can able to draw the pixel. So just you no need to worry about this. Then you calculate the first decision parameter E, and then you just calculate inc1 and inc2 value. So the equations are given like this. Decision parameter E is equal to 2 into dy minus dx. inc1 is 2 into dy minus dx, and inc2 is equal to 2 into dy. So these three formulas you have to remember to calculate the decision parameter and inc1 and inc2 values. So I calculated the same thing here. E is equal to 2 into, that's what, dy minus dx, that is 8 minus 10, then 2 into 8, 16 minus 10, 6. So my first decision parameter value will be E is equal to 6. So you just parallelly open the problem what I solved in the previous class, that Bresenham's line drawing algorithm for the same input value, that is 20 comma 10 and 30 comma 18. You look at the table. You look at the table. I have constructed one table starting from the coordinate value, like iteration from k is equal to 0 to till k is equal to 9, and we have a different decision parameter values, that is p naught values, like 6 4 something 6 2. So you have got the values. Please open that open that notes and just you check it. So you compare my program tracing with the previous problem what we solved. Okay, then you will understand. Okay, so the how the values are computed and how we are going to make the table. So you just look at the table. In there, you in the first iteration you got the value is equal to 6, that is decision parameter pk. So e p naught is equal to 6. Okay, so now just after that I have calculated inc and inc2. So that inc1 is equal to 2 into that, apply that dy minus dx, that you will got the value inc1. Just you solve that by applying the values, and you got inc1 is equal to inc value is equal to minus 4, inc2 8 comma e is equal to 6, inc1 minus 4, inc2 equals to 16. So these are the values I have calculated sequence. Next, my first iteration is going to begin. How many iterations you have to perform? So I have to stop until my I value, the iteration value should be less than dx. Means what is the dx value I got? So I got dx value as 10. So I got dx value as 10. So means I have to perform my iteration from 0 to 9. So yes, 9 is less than 10. Yes, exactly. Is next, if you try to attempt, if for the next iteration 10 is less than 10, no, condition fail, it will come out from the. Okay, means starting from 0th iteration to iteration it is going to perform. So that is what we have to taken care. Okay, so that is the first iteration is started now. I is equal to 0, I is less than 10, I plus plus. So if e is greater than or equal to 0, look at that next time. Just follow step by step. I am explaining. Please follow the same thing. If e is greater than or equal to 0, yes, just go back. What is the e value calculated? 6. 6 is greater than or equal to 0. Yes, condition true. I have put the tick mark. Condition true. It satisfy the condition. Now I am going to, what is the next step? If that is true, then you increment the y value. You increment the y value. What is the y value in the beginning? The value of x is 20, the value of y is 10. Now increment your 10 value by 1. So now 10 value is incremented to 11. Incremented by 1, it is 11. And you calculate the next decision parameter. So you calculate the next decision parameter. So I have started calculating e is equal to e plus inc1. E is the previous value, that is 6 plus minus 4, just 6 minus 4 2. So I got new decision parameter e is equal to 2 for the, it will be useful for the next iteration. Okay, after that the logic goes like this. So next else, if suppose that condition fails, else part will go, but the condition is true, so no need of else. Then once that is done, next you have to increment your x value. So that is what I did here. I have incremented my x value, that is x value will be incremented by 1. So previous steps, what is the x value? It is like 20. Now I have incremented by 1, that is 21. So now I got, after the first iteration, I got my new coordinate value as 21 comma 11. So previous, what is that? 20 comma 11. Now I got 21 comma 11. You just go back to your table and you check it. So you got for the next iteration your e value as 2 and your new coordinate value is 21 comma 11. Definitely we will get the same thing in our problem, in the previous problem what we solved. Okay, so next, once that is done, again it will come back, again it will check for the second iteration if e is greater than or equal to 0. Same thing, same step you have to repeat until that condition fails. So now e, what is the e value? 2, whatever we calculated previous step. So e is 2, 2 is greater than this condition true. Then you increment the y value. The y value will be incremented by 1, that is 20, 12. Previously it is 11, now it is 12. Next, let's calculate the new decision parameter. Again e is equal to e plus that inc1, that is 2 plus minus 4, again minus 2. So now if minus 2 we got, then after that you increment the x value, that is 21 previously, now it is 22. So the new coordinate value will be 22 comma 12 for the third step. So now I will go back for the next iteration. Now the previous calculated e value will be minus 2. If e is greater than or equal to 0, check it. Minus 2 is greater than or equal to 0. No, the condition fails. In for the previous two step, the condition is true, but for the this step, e value is negative. It is not greater than 0. Then condition fails. Then I will go back to my program. So if this condition fails, what you are going to do? You are not performing this one. Directly we will go to the else part. But in the else part, for the negative value, you have to only increment, you have to calculate only the decision parameter. You no need to increment y value. You are going to retain your y value same. You are going to keep the y value same, whatever you have in the previous steps. You no need to increment y value if the negative values, if it is greater than or equal to 0. So that is what I did. I calculated only addition parameter. That is my, but formula is different now. Instead of that e, I'm going to use inc2. So that like this. So that is minus 2 plus 16. So 14 you got. That is e is equal to e plus inc2. What is the e value? That is minus 2. Minus 2 I have written. Plus means that plus inc2. Inc2 so that is 16. Here inc2 16 I have calculated here. This one. Okay. So now after solving e is equal to 14 I got. So after that, what will happen? So next I have to increment my x value. So that is what I did. Again, I incremented my x value. So previous step it is 22. Now it is increment by 21, 23. But there is no change in y value. So y value will be same as in the previous steps. So previous step it is 12. For this step also 12 only. So what is the new coordinate value then we got? X value will be 23 and y value will be 12. I am going to rewrite once again. So now this step is over. So now by taking the new e value, I will go back for the next iteration. Again, if e is again same condition, if e is greater than or equal to 0, 14 is greater than 0, is true. Again, I will go back to the initial step what I did now because this condition is true now. So then I have to increment y value. So here in the previous step, because of negative, I didn't increment y value, only x value I incremented. But again, now here the 14 is greater than 0, yes, true. That's why I'm going to increment y value and again I'm going to calculate the new decision parameter. So again in the previous step is 12, now it is changed to 13 and new e value I'm going to calculate. So next again a 14 minus 4, this apply this values and you will get 10. E is equal to 10. You got e is equal to 10. Then after that next increment the x value by 1. X is equal to then 24. 20 previous 23, now it is 24. So after this step your coordinate value will be like 24 comma 13. Okay, like this you have to perform for all the steps. So what is the previous step value we got? So e is equal to what we got? Is equal to 10, right? 10 we got, I think so. 10 we got. Yes, I'm using same that value here. 10 is greater than or yes, condition true. Increment y value by 1. Then previous it is 13. Now it is 14. Then calculate the new decision parameter. Now we got 6. So e is equal to 6 and then increment the x value by 1. That is previously 24. Now it is 25. New coordinate value will be 25 comma 14. So now again e is equal to 6, right? Yes, if e is greater than or equal to 0, 6 is greater, yes, true, condition is true. Then I will increment y value by 1. Previously it is 14. Previously it is 14. Now it is 15. And again calculate the new decision parameter. Again we got e is equal to 2. Then increment x value. That previously 25. Now it is 26. So new coordinate value will be 26 comma 15. So I will go back again. E is equal to 2 we got, right? S2 is greater than or equal to 0. S condition true. Increment y value by 1. Previously 15. Now 16. You calculate the new decision parameter value. Now we got minus 2 and increment your x value. Previously 26. Now it is 27. So you write once again 27 comma 16. So now e minus 2 I got. Minus 2 is greater than, no, condition fails. So same thing here what we faced in the previous steps. So same once again we have this condition arises. If the condition is failed because of negative value, then again in that case what I have told, you should not increment your y value, only x value you should increment and decision parameter you have to calculate. So here see nowhere I am incrementing y value, but directly I am calculating the my decision parameter, that is e is equal to 14 I got, and I can increment x value by 1, again 28. I am retaining the 16 whatever I have in the previous steps, I am retaining the same y value. no change in y value. Okay, next now I got e is equal to 14. Again 14 is greater than or equal to 0, condition is true. Increment y value, so then previous 16, now it is 17. Then calculate decision parameter, then now this step e is equal to 10 we got, and increment x value by 1, then previous 28, now it is 29. So 29 comma 17 is the new coordinate value. And the next iteration is e is equal to 10, right? 10 is greater as condition true, increment y value by 1, previously 17, now it is 18. So next e is equal to e1 plus, that for you calculate the decision parameter, you got 6. So e is equal to 6, and then increment the x value, previously it is 29, now it is 30. So the new coordinate value will be 30 comma 30 comma 18, 30 comma 18. So now you go back, so now but your value will be for this iteration. So already we have come up, we have reached 9 iterations. Now this condition is going to be fail. So this condition is going to fail, is less than dx. Then after that it will come out of the loop, and it is going to draw the pixel. Means using those all the new coordinated values, it is going to call that function drop pixel function. So once it is called, the drop pixel function is going to start working by taking all these input values whatever we derived now, starting from 20 comma 10 to 30 comma 18. We have around 8 to 9 values. All those values I am going to pass through this vertex function, and then I can able to plot individual pixel or point on the screen. Then after that it looks like line. It will make a line by connecting all these vertices. You can make a line. Okay, that is how you are going to how your draw line function is going to be performed for the given inputs. You can take any values. I have taken simple value. You can give any input values, 100 comma 300. If you give more values means you have to perform so many iterations. If you give little values means it will be wind up in 10 or 15 iterations. If values are more, if your x1 y1 value or x2 y2 value, obviously correspondingly according to that you have the number of iterations will be, obviously it will be more. Okay, that's why I have taken same example in order to convince you, in order to make you understand. So I have taken same example for tracing the lab program, and as well as the theoretical problem solving technique. Okay, so then it will be easy for you to make a comparison between these two. Okay, so after that, that's it. So this function is going to call. So once it is everything, all the pixels has been drawn, then it is going to display your line on the screen. So this is how your program is going to work. Okay, so this is somewhat screenshots I have taken. I will show in the execution also. Just look at that. This is how it is. Once you have an execute, once you have save your program and build your program. So you have to build your program. When you are building, if you have any errors or anything, if you have any issues in the coding, then it will throw an error at the bottom. You can just check it and you can debug the code. After, if everything is fine means it will success, and it will ask for the input values. So what is that? It will ask for x1 y1 and x2 y2 value you have to give. Suppose I have given 100, 200, 300, 400, but in my case, whatever I solved, I have solved for 20 comma 10 and 30 comma 18 I have given. I will show for 2 to 3 different cases after this explanation. So this is how I have given the input, and for this corresponding input I got the line like this. I told, right? So we have then the top left corner, we have this blood create window caption that whatever we are passing the title resonance line drawing. So same thing I mean, if you are giving, see, this is my first CG program, same thing is going to be appear on this location. Okay, so this is how I got the line for this input. So that is 100, 200, 300, 400. Okay, so this is how your resonance line drawing algorithm will work, and this is how to trace your program with line by line. Okay, then it is easy to understand, and for even for you people also easy to learn. So for the lab exam. Okay, so that is the overall explanation about your resonance line drawing algorithm with respect to laboratory. Okay, so now how to execute this program, the next question. So next you have to install, as I said, Microsoft Visual C++ 2008 you should install. You follow the instructions I have given and you execute that, sorry, you install that. It's somewhat it looks like this. See, So Visual C++ 2000, this edition I have installed. Okay, so and you will get the Windows something like this, the programming area where you have to type your program. So I will show this here how to open and all those things. So okay, so we just see before that, anyhow I already opened. I will show the execution of this, and I will show how to open a new program which you want to do from your end. Okay, so this is the code what I explained. So same thing I've written here. Okay, so once your program is ready, okay, so you have to, it's case sensitive, you have to use wherever capital letter, wherever small letter is there, you have to use that, you should remember. Okay, and space also you should not give any unnecessary spaces. So this, so GL space clear space color, this won't work. So this complete GL clear color is a single function. So that's why you have to refer all the inbuilt function, otherwise it will throw error, or sometimes it will not show that error also, but you will not get the output. So all these you should taken care. So all the case sensitive and spaces, everything you should take care. Okay, even this underscore or operator wherever we're using, so everything you should concentrate. So once you have type your program, just you save your program here, and your before that only your program name, it will ask for the program name when you open the new project. There you have to by default it is going to save as a CPP program only. So once it is saved, just go to the build option. Here build solution you have to give. Here at the bottom it will show. Okay, if any errors is there, it will come here. It will show the error. If not means you can go for, see, it will start building. It will show if any errors comes, it will show here. Otherwise, directly you can go for execution. There is a like, or is a triangular button. So this is for start executing your program. Just click on that. So you will get the window, a pop-up window. So your window, you're going to get the like this. It will ask for the input values x1, y1 and x2, y2 value. So now I will give the input whatever I solved just now, that is 20 comma 10, that is x1 y1 value, and 30 comma 18. So this is the x2 y2 value. Just after giving the input value, just you press enter. So this is what the display window I said, right? So it is the size will be like 500 500, and it is starting from the origin 0 comma 0. So so this is how you are going to visualize your display window. And as I said, no, resonance line drawing, it will show the name, and you have the option all these things, cancel and minimize and maximize and full screen. And this is the where you are going to see the output. This is the line, just see a small line, because my input value is very small. That's why very less number of iterations we perform. And why that's why, and we have only some 8 to 10 pixels are there to draw. That's why it is a simple small line we can able to see. Just if you want to make it full screen, just you can see. So these are the how we are going to. So when you expand it, you can able to see the dots. Otherwise it looks like a line only. That is what we are telling. Even your, if you are even in your mobile also, for your picture, if you are trying to keep on zooming, if maximum zoom, if you are trying to do your face, then it again you can able to identify the small dots, you can able to identify. So those are only the pixels. All pixels will join together and form a picture, a complete picture it gives. Okay, so that's what. So just here you can, previous case you can't able to see, but you look at here, now you can able to see individual pixels. So this is what the initial point, that is 20 comma 10, and this is what the 30 comma 18. Okay, and these are the in between pixels, whatever the value we have calculated just now. This is how you are going to get the output. This is all about the execution part. Okay, now I will try to give one more another inputs for the same program. Just you re-execute your program, and I'm going to give the input value like suppose 200, anything you can give, 200, 150 and 300, 250. So I'll give, okay. See, for this somewhat again different input line we got. Just so look at this. No one will draw the line here. So all your pixels is, or all pixels are joined together and it looks like a line. Okay, this is how you are going to get the line with respect to Bresenham's. Okay, so just make it expand. See, look at now you clearly. when you are minimizing, just you looks like a it's a complete straight line you can able to visualize, right? Just if I want to make it a full screen, then you can easily see. So these many iterations we have performed for the given inputs and we have computed, see, 1 pixel, second, third, 4, 5, 6, 7, 8, 9 till the end pixel. Okay, so this these pixels will looks make or looks like a line. Okay, just look at this. So this is what the difference you can observe in this case. Like this you have to give your own input, and you can, that's a small value if you take means you can able to trace it out. If you take larger value means it's very difficult to perform all so many iterations when you are calculating manually. That's why take the lower value. When you are going to trace, you give more value to get the better output. Okay, so when you are executing even in the main examination also. Okay, so this is about the execution part of the Bresenham's line drawing algorithm. Now, suppose if you are trying from your end after installing this, so how to do that? So just you go back once it is installed and opened like this, your Visual Studio. Just go to File, go to the new project you have to create like this CGV what I have created. Similarly, you go to the new project. So here Windows 32 it will be there. Obviously Windows 32 console applications you have to choose. You can give the file program name here. So like CG program, whatever you want, you can give the file name here, CG program. Just you give the program name here, and then if you want to change the location, you can change it to save your program. So okay, then I will go to click on OK. You have to click OK, then it one more pop-up window will come. It's asking something. So welcome to 32 Win32 application wizard. You no need to worry about it. Is already console application. Just you click finish from any window to accept the current settings. After you create the project, don't click on the finish, just go to the next, and you just check here. Okay, just you want empty project, just you take that empty project, then finish it off. Okay, here you will get CG program and all these things. You click on this. There you are, just click on add item on the source file. Here just you check C++ file CPP you have to choose. By default it will be there, but once verify. Okay, and give the file name. Suppose you want to draw circle algorithm, suppose circle, you can give the file name like that. Then you can give the location also, otherwise the default let it be, no problem. Then add, it will come here next. See, like this I got circle.cpp. Previous what happened in my previous program, it is Bresenham's.cpp was there. Now you have to create circle algorithm. If you can give any name, whatever you want. Okay, just you click it. You got the program area where you are going to type your program. You just start typing program like hash include. Um, let.h, like this you can keep on typing your program. Once done, just you go to click on save button, and you go to build solution, you just execute. Once that done, what you have to do after typing your program, save it, go to build the solution. If any error, you will get the error here. Okay, what error you are going to get, you have to debug it. Then again, once again you have to build. Then once that is without any error, if it is executed, then you can go for the execution. Okay, so just you have to click on this icon, then your program is going to be executing. It will ask for the input. If any manual inputs required, it will ask. If no manual inputs, because for all the program it will not ask for the manual inputs. Some of the program it will take inside the program itself. that time it will directly execute, it will directly show the output on the screen. You no need to give any manual input. As this is a line drawing and we need some input parameters, we have to give the, then one pop-up window will come. The anyhow I already showed, right? So you have to give the x1 y1 x2 y2 value, then after that you will get the output window. But in some of the cases you no need to give, directly will get the output after clicking on this button. So this is how you have to execute. Okay, so just simple what I did, you go to file, go to the new project and give the name. I have given CG program for my case. Then you follow the steps what I have told it, then after that you will get like this. Okay, so then after once you got like this, just you click on the source file, add, you go to add new item, and then you give the name or what name you want to give. Obviously it will be in the by default .cpp version. Then click OK, then you will get like this. So this is the area you are going to type your program, and again save, build solution. If any error, debug it, again build and again execute. This is the running the program. Okay, so this is how your CG programs are going to be executed. Okay, so please follow these steps from your side, from in your system, and execute this program in today's class, Monday class, Monday afternoon laboratory session 2 to 4. Just if you have any doubts, please let me know. So we will try to solve your problems. Okay, so then in the next class we are going to work on the second program, that is a general scan line algorithm. Anyhow, that is we are already discussing in theory class. So we have one algorithm with respect to filling your polygons, color filling. Okay, so that program we are going to execute in the next class. Okay, so that we will finish two programs in our CG lab. Okay, so then I will discuss, I will share the Google sheet in the next week, as I said. So please you just try to find out the topics, so what no on what applications you are trying to build using CG OpenGL. Okay, so please just you Google it and you try to find out the titles. I will share the Google sheet so that you can able to enter it. Then after executing 2 to 3 programs, then you will get some idea about CG and OpenGL, so that you can start working on your mini project. Okay, so that we will do it at the earliest, and we will finish it your lab and your mini project as early as possible, so before the deadline. Okay, so thank you.